In this lesson, we're going to talk about solving a system of equations by substitution. So some simple substitution that we're going to talk about is, suppose we have two equations. We have x plus 6 equals 11, where x equals 5. Well, if we know that x is equivalent to 5, and take the x away and replace it with the 5 because they are equal to each other, we still end up with a true statement because 5 and x are equivalent values. So when we substitute an equivalent value, we still get a true statement which we can use to solve. So when we have a system of equations that are set up to solve by substitution, we're going to take an expression and substitute it in for one of the variables. When solving a system of equations by substitution, typically one equation is going to be in our standard form with x and y on the same side, and another equation is going to be in our slope-intercept form. So it's not really set up the best for graphing, but it is set up for substitution where we have one equation where the x and y's are on the same side, and one equation where they're on separate sides in our slope-intercept form. So to solve this by substitution, if you notice we have x plus y equals 8, and y is equivalent to the expression x plus 2. So if we circle that expression, y is equivalent to x plus 2. Therefore, I can replace it. I can substitute it in for the y in the equation above it. So instead of having this y right here, I'm instead going to replace it because y and x plus 2 are equivalent. They are similar, they are equivalent expressions. So I'm going to take out this y and replace it with x plus 2. I still have an equivalent expression, an equivalent equation. I just changed the expression so that now the only variable in this equation is an x. And now I can solve it. So I would start by combining like terms. Now my pen's working. Combine like terms, I have 1x and 1x. That would combine to be 2x plus 2 equals 8. Now I need to subtract 2 on both sides, and I get 2x equals 6. Divide by 2, and I get x equals 3. Now remember, when you solve a system of equations, we need an x value and we need a y value. So to find y, I go back to the problem and I see this expression. Y equals x plus 2. Well, again, I'm going to substitute that x with the 3 that I found. Since x is equivalent to 3, we put that in the problem. We say y equals 3 plus 2. So my answer is y equals 5. So the answer to this system is x equals 3 and y equals 5. Now I'm going to show you one more example that's a little more challenging. So again, our equations are set up. One is typically in slope-intercept form. One is in the form where we call it standard form, where the x and y are on the same side. Step 1 is to find that slope-intercept form one where y equals this expression 2x minus 2. we're going to take that expression and replace it for the y. Now remember, you can only replace the y. I can't replace the negative 2 that's out front of it. So when I rewrite this equation, the 3x minus 2, I'm going to put parentheses, because that's what I'm going to replace it with, and set it equal to 11. So I rewrite everything except for the y. And I'm going to plug in the expression that y is equal to, which is 2x minus 2. Now it's just a long equation that I can solve. Step 1 says I got to distribute the negative 2. So we get 3x minus 4x plus 4 equals 11. Combine 3x minus 4x, that gives me negative x plus 4 equals 11. Now I got to combine, so I subtract 4. Get negative x equals 7. Can't have a negative 1 out there, so I divide by negative 1. And I get x equals negative 7. I take that x equals negative 7 and I use it to find y from our original. If y equals 2x minus 2, well, y is going to equal 2 times, my x is negative 7, minus 2. So y equals negative 14 minus 2 would be negative 16. So remember to always substitute in, and once you do, you always have to distribute this number. Whether it's a negative 1, whether it's a negative 2, whether it's a positive 3, always distribute that number inside the parentheses.